here's a great example of that. This is bad because of the inductance in the traces. Now what I'm showing here is the old way to do this, which works great for analog, don't work for digital. So this capacitor here is connected to these vias, and they go to the power planes. Now there's inductance on these wires. So these wires, instead of going to the power planes directly, they're going to the capacitor directly. Notice there's no vias here. So the closest connection to the power planes is on these vias here. Now as the capacitance, as the frequencies go up, this capacitor becomes less and less useful, and sometimes you need some interplanar capacitance. Imagine though going through this inductance. So this is bad for several reasons, and the biggest one is this is a much bigger inductance way of doing the same thing, and I'll show you a better example after this next slide. I love this slide just to break up the monotony. I know some of you guys are probably going to sleep right now, so please stay awake. I know this is a virtual event, and it's really going to be not the same. I wish I could be animated in front of you, but I can't. So just look at this slide and realize that just because you've always done it this way doesn't mean it's not incredibly stupid. So what is the right way to do it? The better way would be instead to have the capacitor go directly as quickly as possible to vias to the power plane, and at the same time do the same thing with the processor. And why is this better? Mainly because the distance, now notice the distance from the capacitor to the processor is the same in both slides. The difference is the connection between the vias, which would be the same as the trace in the last slide, is going to be significantly less inductance because it's connected directly to the planes, which are much lower inductance because the copper is significantly wider, and there's a lot of other reasons. Part of it is if you do your PCB stack up to allow some interplanar capacitance, that is a huge deal as well. You can find a lot of information about about pad to vias connections, which are the best. Now some people say, well, actually I think the common thing to say is that vias on the side of the pads, just like this, are the best instead of vias on the ends, because the loop area is slightly smaller than vias on the ends. Now if you wanted to reduce it even further, you could put another set of vias on the other side of the capacitor pads, and that would be even smaller. But they talk about, you know, that as if that's the whole picture, but what it really, the whole picture is how much effective capacitance can you fit in a certain area. Now this is something I would love to do some studies on, but unfortunately I don't have access to the software that does these simulations anymore. But what I'd like to see is how can you have an area that's going to be, you know, maybe 20 or so bypass capacitors that's going to be the most effective. Because if you do vias on the side like this, then that's really great from an inductance perspective, but it's certainly not good from a density perspective, a density of capacitors. You could certainly put more capacitors if the vias were on the ends. So if someone wants to do that, please let me know what you find. I'd love to see that. Okay, so let's talk a little bit about routed power. How many of you have used ferrite beads? Okay, I see that hand. I wish I could see that hand. This